So today we are going to work with the data that we have. So I don't want us to waste time, so we'll just make use of the data that we have. I think this one, I hope it's saved. This one. Okay, so this is where we stopped it yesterday. Before I ask you to do yours, of course, we brought in MatplotLib, MatplotLib library. All right, so that is where we're going to start from. Assuming we have data and then we want to plot, it's independent of the other, but maybe we want to visualize it on graph. We want to visualize our results on graph and see how this shows up on graph. And you know, like I said, they are independent. You can have, you draw graph normally, your pie charts, your scatter diagram, your histograms, you know, whatever charts you want to draw. So based on context, based on what is relevant to the data in context. All right, so we've been able to install MatplotLib library yesterday, and we started using it before I stopped, and then I asked us to do the exercise. All right, so assuming we import the matplot library from the same place where we have everything imported, so that our program will look modular. So I'm going to come here and import the matplot library, the pie plot of matplot library. So assuming I have import matplot library dot pie plots. All right, so let's say we import that as PLTs for conveniency. All right, so assuming I test if I don't have any issue. So please, like as usual, I need us to call along, so everybody follow through, so we don't play catch-ups. Okay, please, are we on the same page? So the next thing I'm going to do is to make use of this plot to plot my data. So let me return this guy to Olympics. See, the execution is pretty slow. I don't know. Has everything loaded properly? Okay, great. All right, so just so that we concentrate on one. So now that's to plot graph. All right, now so to plot our graph, I'm going to have two axes plotted. Okay, so here let's say we have plot dot if you use scatter diagram. Now we are plotting, which data is this one? Okay, it's the one with x, or I think I want to do the one with x, and I ask you guys to do this one, but it's fine. Let me do this one, and then you guys would use the second one as an exercise. So assuming we use this one, scatter diagram, and then remember that x is bivariate in this instance. We have athletes and we have previous medal, and when you're plotting a graph, everybody have to bear their father's name. All right, so we are going to have this guy separated, athletes against y and previous medal against y. So when we are plotting here, we are not plotting x directly, but then we are plotting, you know, the values within the x. So here, let's say we say these athletes, I hope I have it spelled correctly, that is the x-axis. Normally before this, your scatter diagram takes x, y value. You know, the graph is two-dimensional, x and y, x and y axis. So you pass in the x value and you pass in the y value. Essentially, that's what it requires. Okay, so if we pass in the x value in this case, which is the athletes, let's say that's the first one we want to plot, athletes, our x value contain athletes. Remember, this is the x value, so some people will be, this is the x value, athletes and previous medals. Now, so we want to plot athletes against y, and then athletes previous medal against this thing on the same axis. So that's what we want to do. So I'm going to have that as athletes, and then I have my y-axis as y. So I have my y-axis as y. Okay, so if we have that out, see my scatter, scatter is SCA. All right, x is not defined because I have not run the cells. So let me run all the cells. Let's run all the cells. So it records all the variables. Restart kernel and run all the cells. So all the variables are run into the memory. Because this is done since yesterday, and the server is just powered up, so he has forgotten everything. Now the sense is back, senses are back. Now the senses are back, and then this is plotted. Now we can pass in an optional argument, which is the third one, if we want to dictate the color that this appears in. This is this one. This is y, athletes against y. We may want to dictate certain color. Let's say we don't want blue, we want certain color. So we can pass in an optional third argument, which is the color in this instance. So if we pass in color, we can say it should appear in red instead. So if you do that, this appears in red rather than appearing in the default blue that it appeared in. In any case, that is if you have preferences, and of course if you have in this case where we have multiple data points to plot. Okay, so that plots that out, and it gives us the graph of athletes against y. Now on the same axis, let's say we plot again, this time around, x, the previous medals, I think is spelled this way, previous methods or previous methods. Sorry, I'm just doing like all right, so previous methods against y. Still we can have that on that same axis. So this is not close. Sorry, I'm just does not match. Look at what I've written. So you have this like this. All right, so that plot that out. The first one is this. The blue is the previous medal, and the red is the scatter diagram, but nothing shows that on the graph. So we want to label the graph and say that blue is the previous medal, and say that red is the athletes. All right, so to do that we use, so if you can go, if you see, there are a couple of methods under the plots, so let's say I have that plot and then I put text. Okay, so if we use text to write anything on the graph, so when you're putting anything on this graph, on this graph here, you want to specify the position of that thing that you're putting in it. So if you don't put it, it's going to 0 and 0, it stays here. So this is x, of course this is x, and this is y axis. Okay, so if you say that, if you specify certain value as the position towards x, and then you specify certain value as position towards y, this is y axis. So if you want it to be somewhere here, this is 400. So if you want it to be somewhere here, then you're going to put it maybe 400 and something. That stays here. If you took 200 and something, this is for y, it stays here. If you want it somewhere here, then you target the value of x, and this, I don't know if you are seeing my my cursor. All right, so if we come in here now and say that we want it just in the region of this 400 plus here, so I'm just going to say that for x, maybe 100, because this is 0 and this is 200, so 100 will be in between here, so it should be up here. So for x I say 100, and then for y, let's say for 400. That's the position of the text I'm about to write. I can put it anywhere, but you are just trying to specify where it should be. And then the text now, so you can say that the athletes is blue. And then you can also put that color in blue. Sorry, athlete is the red. I think athlete is the first one we did. So athlete is the red, and then you can put the color in red. We can put the color in red like this. So if you run this graph, you see athlete equals to red, being positioned in the axis that you specify, in the position that you specify. If you change this one, for instance, to say 410, you'll see it jump up a little bit. If you make it like 90, you see it coming close here. If you make it like 50, you see it coming into that region. Please, are we following? Am I audible? So that it won't be like the other day.
Yes.
All right, great. So you can label that, and then label the second one as well. So you can label the give the second label as well. This time around, this one is previous medals. You see that is blue, and maybe you want to specify the color to be blue as well. Okay, so if you do that, you see that our graph's taking shape. Both of them are on the same position, so it doesn't make sense. So let's say we put one above the other. Let's say this one stays at 430, and then so that it stays above it, or 450. Yeah, something like that, so you can do your positioning properly. We may also want to label the axis, because this our axis doesn't, this our y-axis doesn't have this thing, so we can label y-axis and also label the x-axis. So if you say plot dot x label and then you can give it any label of choice. So let's say you label it you give it a label, say x values. All right, so you have that x values here, and then you can have your y label as well, y label, which is equals to, let's say you say y values, or whatever value you want to give it. So you give this like that, and then you have that plotted, you have that y value. So pretty much a couple of things that's this thing. So yesterday I wanted us to put this one dynamically, because you are putting this 50 and 40 because you are seeing the data. You saw what the graph says, so you are doing that manually, assuming the data the data is not something that you actually see. You want to automate the position of this guy such that it doesn't cover your data. So what you want to do is to get the maximum value of your x and your maximum value of y, and then position it above that maximum value, so you can scale your graph. You see, this our graph stops at 400, so maybe you want to scale the graph so that it goes beyond that. You can do something like this. If you do plot dot scale, or axis rather, so we use axis, and then you put let's say 0, comma, that is the x value. The first two value represent the x value. Let's say 0, comma, where did this one end? 800. So let's say I say 1000 or 1500 or 1600 or something like that. That extends the axis here. This graph will be bigger. So x, we are saying that x should start at 0 and x should end at 1000, and then y should also start at 0. Maybe y should also end at 600 instead of 400. So if you do this and do this axis again, I forgot this comma here, I don't know. So if you do that, you'll see that's showing up 0, 1000, from 0 to 1 position argument, but 4 arguments is given. Yeah, sorry. So this is meant to be this. You are meant to put it like this, double, put it in envelope. So that way you have that 600, and then you have this is 1000, And then so you can see that instead of it stopping at 400, it had extended into this one. So it gives you ample space to put this your label, so it doesn't cover, you don't stand a risk of your labels covering any of your data. So if you do that, you may then want to put whatever you put here, maybe that's where you want to put your guys here. So let's say this guy, we raise it to 500, but you could do that so 550. All right, so if you do this, so it should look a bit better now. And then sometimes you may also want your graph to have grid, depending on what graph. This one, it doesn't make sense for you to have grid. You may want to have grid, plot.grid. If you want grid, we all know what grid is. So if you want a grid, you just pass in grid and then true. So doing that gives your graph the grid, so that you can, it's easier to read if you want to do that. So you may want to do this. You may also want to join your points if you have to join your points. So if you want to join your points, you just say plot dot the actual plots, plots dot plot, like this. So, and then that would plot what are you plotting. So let's say you want to join the athletes. You want to join the athletes, so you can have it like this. So let's say we plot this guy here. So you see the athletes values are joined, though it's not looking sexy, but then it's not looking good, sorry. The second one is this. Plots, and then you have this like this. All right, so so that's if you want to join your point, right? So this is just an idea to just take us through a couple of things that you can do with your matplot that you have. All right, please, I want to assume that everybody is coding along. Are we?
Yeah.
We are, right?
Yeah,
Sir?
I said, can you slow down a little bit?
Okay, so I will slow down a little bit for you. Please quickly capture. While you are capturing, I will pause the video so that there won't be so much silence for those that will be following through the video. So go ahead, sir. I'm waiting. When you are done, let me know. This is a bit that we're going to do here. The next thing we're going to be doing is using a machine learning model. This one here, we built that model, mathematical model ourselves, but we're going to be using an existing machine learning model, and then we'll be using that to first of all work on the data that we worked on, and then move into working outside the data sets of our implementation. So let me save this as so let me say, where is it? So let's rename this as exercise and pie plots. Alright, so the next thing I'm going to do is open a new file entirely. I'll open a new file entirely and a new notebook, so we start this one on a clean slate. Alright, so the next thing we want to talk about is using one of the popular machine learning this model that is out there, Scikit Scikit Learn. So it has an history. Started officially in 2007 and has grown, wings from then. Started from Google Summer, coding, summer code on whatever they call it in 2007. So it's one of the simple and robust machine learning model out there. It's one of the ones that we are going to be exploring. Yeah, there are a couple more. All right, so just as we have done with other packages that we have, for us to use Scikit Learn, you have to install it. And to install Scikit Learn, there are some prerequisites, SciPy, NumPy, and a couple of more, SciPy and Matplot library. The Scikit Learn is built on top of some of these packages. So if you try to install the Scikit Learn and you don't have all these prerequisites, it's going to, of course, install all the required packages and then install itself. So even if you don't have some of these packages, but I think we've installed a couple of them, Scikit, the installer will install all the required packages. So the first thing I want us to do will be to run to our terminal and install sklearn. All right, sklearn. So let's go to the terminal first and run pip install sklearn. So you're going to have pip install sklearn. I want to see the this thing that is called. So I have the site open here, sklearn. All right, so the sklearn, this is it. All right, so to just install it, you simply just use pip install. This is Scikit Learn. This is what I was looking for, Scikit Learn here. Pipe install this, or pip install that. So if you have it installed before, you see saying requirement already satisfied. But if you don't have it, it will install all that is required. JobLib, NumPy, SciPy, Scikit Learn, everything will be installed. Please, let's do the installation, and when we are done, let me know so we can write on.
So please, can you drop the full name on the
All right,
comments?
the full name on the comments, Scikit Learn. So where is that guy again? So you use it like this. Pip install something like this. All right, someone said they are good, but I want to carry everybody along. I know that you're good, Mr. Suleiman, but a lot of people are not talking.
It's still installing. It's taking a little bit of
So
time to
let's
install.
I want us, because this is what we want to work with. If you don't have it installed, you'll not be able to follow. It looks like you're watching movie and everything will just becoming complicated. So feel free to ask us to wait for you. If you don't have it installed, and if you are installing it through Conda, it's the same thing, but instead of pip, we just use Conda install. Conda install Scikit Learn if we're using it through Conda, through Anaconda. So you just say Conda install this guy, and that would install that guy. Please let me know when to continue so that we can all right, so we are starting this new clean slate. Let me reduce it a bit so that everything gets fit in. So the first thing we want to do is to use this Scikit Learn to check, use it to work on the same data that we have worked on, right? So I'm going to say from sklearn dot linear model. So sklearn has several methods in there, several algorithms, linear regression, logistic regression, which is also in the linear regression anyway. So we have classifications and all of that. So there's a lot in it. So let's say we import linear model from this sklearn. So from sklearn, let's import linear regression. Linear regression. It has to match word for word from what we have in the linear regression. So you can also import from that. You can import it as something as if you want. Okay. So that would import our distance for us. Then the next thing we want to do is to import our usual pandas, because we need to read the data in, assuming we have not even worked on that one before. So let's say we import pandas. If you give it an alias, if you like, let's say you import it as PD, or you just keep it as pandas as you want. So let's say the data we want to work on is any of the data set that we have worked on, either the Olympics, either the data, or the data sets. So either any of them. So let's say we use the Olympics data. Olympics data, right? All right. So if we get that, we use the PD underscore read CSV, and then we read this guy in. We read this guy into the memory. What is the name of that file? Olympics. Olympics as spelled, right? We haven't done anything special than just bringing in the data that we want to use our model on. But this time around, we don't really know what is going on. Our own is just to pass in our parameter or our data to the machine learning, and it's get it out. Olympics.
You didn't have the .csv.
Oh, thank you, Jerry. Thank you. .csv extension. All right. That reads that out for us. So the next thing we want to do is to pass in our linear regression model. So our linear regression model, so let's model be equal to, let model be equal to the regression model that we have. So we just instantiate that to be equals to linear regression that we brought in from here, all things being equal. If I didn't spell it wrongly, that is the model, linear regression model that you want to use. So you just instantiate it here, model equals to linear regression. Okay, so this model, the Scikit Learn model, takes two parameter. First at least two parameter, then you have an optional third. Now the parameter are the data fit. You fit in the independent variable. This is the syntax here. Let me write it as a comment. You put in the independent variable, and then comma the dependent variable. So once you do that, you teach it the data. The next thing is just ask it what is r square. It will give you r square. What is coefficient? It will just give you everything out like that. So your own is just to pass in the x value and the y value. All right, so and that is what we're about to what we're about to do. Now, for us to be able to pass that in successfully, we need to get out our x and of course get out our y. So based on this data, how we use it, so that we can compare the results of what we did manually and what we did by this model, the machine learning model, Scikit Learn. So we are going to have, let's say x is equals to, we have this as Olympics, and then we copy out athletes. We copy out the athletes and the, was it athletes? Yes, number of athletes. We use athletes, and then we equally make use of the previous medals. So we use this as our x, okay, as our x value. So if we do this, we have it copied out. Okay, a copy of that. Then let's see, to just be sure that we don't have typos, we have x. So the next thing we want to do is that we want to pass in the categorical value into the x. So let's say x, we put the intercept, which is the unity intercepts. All right, so let's say I call that intercept, and then we pass that to be 1, and then we get out what x is. We got that, just like we did too. For the sake of being correct, we would rearrange it such that that one, we just like we worked on it yesterday. Please, are we following, everyone? So we have x such that we have all of this, except that we are rearranging it that intercepts come first. Except that we are rearranging it that intercept come first. So if we have this, and then we get x now, we would have the same value. So that is our x value that we are going to pass into our fit method of our model, and then we get our y value out as well. we're going to get our y value out. So let me run this in another cell. So while is from the Olympics Olympics, and then we get out the medals. That's the y value. We get out this y value here. So we have that. Then the next thing, yeah, we have that copied out as well. So the next thing is to be sure that we are good. So we have our y value. All right, so the next thing is just fitting your model, fitting your data into the model. So that is, you are training it. So this fit is really training. So you give it the data. But let's see, the whole thing would become clearer as we move on. So if we have our model that we declare up here, the model that we declare up here, which is the linear regression that we're about to use. So we'll just pass in, I hope I'm recording, yeah. So we just pass in the fit, model.fit. So we pass in x value and the y value as we've gotten it. We declare them as x and y. All right, that's all we have to do, and we are done. This is all you have to do. You're done. The rest is to get results. Pass in the value. The rest is to get results. So let's get results. You say model dot. So in your model, you can have coefficients. I hope this linear regression. So let me get out this linear regression and be sure that let me do this model so that sometimes I write typo. I'm sure that it's fine. Okay, so I just use dot. I wanted you to bring out this guy, the IntelliSense. So all of these you can get from that your model, the coefficients, the feature name, the intercept values, the the positive value, the prediction, and of course the score. So let's say we say model dot coefficient. That's the first thing we want to get out, coefficient. And then if we play that, you see what the coefficients this gave us. We have 0.0711 to this thing. So let's compare that with the coefficients that we got from the from the original model that we wrote. So I suppose this is it. This one, yes. So the coefficient is this is the coefficient that we had, 0.071112, 0.071112. So if you look at the one that this guy got, 7112, just that there are more decimal places. So we see the second one too, we have 0.73417. So if you see this one too, 0.7, so it just has more decimal places. Then also, now let's predict value. Our predicted value for the manual method that we did are this is our prediction. We look at this, remember this is our prediction. Our prediction stands like this. So let's see what this guy would also predict. So for us to do the prediction, so let's say prediction here, prediction, I don't know what prediction is equals to your model dot predict, then you pass in the x value. So now let's see what the prediction look like. Now, so if you look at the prediction, which of course is an array, you have here, you have the minus 1.39, this thing, that's the first value. Compare that to what we got here, minus 1.39, you know, the second one like that. So our model that we wrote manually, you know, got, you know, approximately the same results as the Scikit machine learning. So please, I hope we are coding along, please. Yes, I can hear you.
Well, I am coding along, but it seems my own model is far different from yours.
What happened?
I got multiple. I got multiple data.
You got multiple data.
Like
Can you check
yes, kind of like
what you passed in? Are we working on the same data?
we're working on the same data, the
Olympic
Olympic data.
data. Is this the X value that you passed in?
Yes, I pass in the same X values. Yes,
Like this, with this intercept, with this arrangement and everything.
exactly, sir.
And you passed in Y as medals.
Yes, yes,
Okay, so
yes.
can we look at your screen then?
In fact, okay, I
So
think that's
let's look at
better.
your screen. So let's see what the discrepancy is.
Can you see my screen?
Yeah, maybe you need to zoom in a little bit. It's like let's go up, sir. Go up. Okay, let's come down. Wait. Let's take it slowly. Athletes, previous medal. Okay, let's come down a bit more.
I think you should check. Okay.
Yeah, please, everybody, please put an eye. Uh,
I'm saying something like a model equals to LR. Did you use alias
I
for
think he
your linear
used
regression?
co-op. Did he use Elias there? I think he used Elias at the top. Yeah, he used Elias as LR.
Okay. Okay.
Sorry,
He
could
wrote
it be this?
logistic regression, not linear regression.
Linear regression is wrong. The
Oh,
spelling.
logistic regression is what you are using,
Regression.
Oga.
Thank you
Is
very
linear
much.
regression.
Your SKL, is it correct?
Yeah, I think we are pretty much speaking the same language now.
Yeah, we are good now.
You're
Thank you very
welcome.
much. Yeah.
So you may stop sharing now. All right, so good. Someone raised hand. Please go ahead.
So please, the my intelligence is not showing. I've tried to troubleshoot. I don't know why. I don't know if there's anything I will
No,
install
no, you
before it
don't need
can
to
show.
install anything. I think you are using a Windows system. Sometimes it's the memory of the
Yeah,
system.
I'm using Windows.
Sometimes it affects it. If the system, there's a lot going on at the time. You know, when you try to press it. So also just put your dots. press that tab. Once you press tab, it will show. Even on my own too, you see, sometimes it takes time for it to show, you know. So it's not, you don't have to install anything, just do your stuff, press your tab. But what affects it is the workload that is happening at the time, so it might take some minutes before it comes up.
Okay.
You're welcome.
Thank you.
Okay, please, are we okay?
Right on, sir.
Okay, please get the prediction, so you can compare that prediction with the prediction that we have, and then you can, the next thing we want to do is we're going to measure it. We're going to measure the prediction and see and get out the score or the measure of accuracy. All right, so let's import metrics. Let's import metrics. Let's import metrics. Please, am I sharing my screen? I can't. All right, so I'm just going to, from Scikit Learn dot metrics. Then I'm going to get out accuracy score. So I'm going to import accuracy score. All right, so we're going to be using accuracy score to get out our measure of accuracy, of course, our R-square. So please, let's get this guy imported. You can also import it as an alias if you want, and then we'll just use it in a bit. Please give me 1 second. Continue. Please, we have everybody's attention.
Yes,
all right, thank you very much. So the next thing we want to do is to check these are check the accuracy of the data that we just got out, and then we did that by, we want to do that by using the accuracy score from the Scikit Learn metrics. All right, so all we need to just do is just use that accuracy score as imported, which takes 2 param. It takes 2 param, the y value with the prediction, the predicted value here. So all things being equal, if we get that out, the accuracy score is not defined. I think, did we run this? Did we import at a later time after this? As so, let's run this cell. So the accuracy, okay, no, where is it? Okay, here. We run this cell so that our accuracy, this thing is loaded. So let's run this guy again. Okay. Classification. So sorry, the accuracy score is actually for classification problem, and this one is just a linear regression is a prediction problem, so we are not classifying. So for us to get the accuracy of what we do is r square, really. We just use r square. R square is what we need to import. So we run that so that we ensure that r square comes into the memory, and then we use that guy to use the R squared to check the accuracy of this, all things being equal. So we get 0.8723. So we can compare this with the R squared that we calculated manually from this one. The R squared that we got manually is 0. Look at it, R squared is 0.72329. If you compare that with what we have here, 0.72329. Of course, it's accurate. So there's a bit of this thing. So let's go through what we did again. We imported what?
0.87, not 0.7.
0.87, yes. 0.8723.
Yes.
0.8723, right? This is the one we did manually, right? And this is the one that we did with Scikit Learn. So just confirming that all our manual efforts make sense. And if you look at it, it's very straightforward. The only thing you need to do is just bring in your linear regression from your linear model, and then you use your Panda to read in the data. And this is like, let's say you have your own data, you could actually use sklearn data to random data, but you are not doing anything, you're just doing random stuff. But let's say you have certain data that you want to work with, we read it in with our pandas, just like we read the other one in with our pandas as well. Then we got out our dependent variable and independent variable. We copied it out from the data that we have, normally, just like with that one, and we'll pass in the unit value to the x value, so it makes it a complete x value. And then we have y value copied out. So all we need to do is just pass in the x and y value, and then that gives us the coefficient. From there we can get the coefficient out. We compared it with what we got manually. It works. We predict the y value, that's the medals now, and then we compare our prediction with the manual method. We saw that we are in line, and R square is in line with the R square that we got from that as well. So before we move into the classification problem, we just need you, just like we did yesterday. I think it's a good exercise for you. I do this one is the one that is difficult, using 2 columns. The other ones are just 1 column that we use as x-axis. So I think we should work with let's work with the data, this data set, this xy. Let's work with this using this Scikit Learn. You are the one doing it. I'll be on pause, and then we'll give us a couple of minutes. Once you finish, we'll then do it together. So once we do this one again, we run this one with Scikit Learn, we can move into classification problem. So we know that we are done with the linear problem. So we'll go for classification. Does that work? I'm not hearing anything. The wavelength is low. It's a Friday. It looks like some people want to go out, or the week has been hectic, kind of. We're using this data here. Use this data with Scikit Learn. Please, we have only 5 minutes to do that. Use this data, this one here. Create a new this thing entirely. Please do not just replace what we did here. Write your own. Don't just replace this one. Write your own. So let me rename this. I'll call it so I'm going to have this guy post so that we can. Yeah, so Mr. Kibu, share your screen. Let's see your solution.
Can you see my screen?
Yes. Please, you need to zoom it a bit.
Yeah, sorry. Okay, we're going to push it. Okay, is it good?
Good.
So basically, I just went through the same thing we did for the first example. All the imports statements using the data, the CSV file. So copy the X column, getting X variable, intersect, and setting intersect to come first. Here I got Y variable. And then, so even though I think the only difference I noticed is that my prediction here, I had more, the output gave me more columns or rows rather compared to
No, I think
the manual
it should be
implementation.
the same. That one truncated it. It put some
Truncated,
thing in
yeah.
between.
Okay. Okay.
Yeah. So
Okay.
and your R square
Yeah. So then,
is 98 point. I think that's what we got
yeah,
yesterday.
yeah, that's what we
Okay,
got.
perfect. Yeah, it's the same. It's on display. All right. Nice one. Nice one. Yeah,
Alright,
we're
thank
making
you.
progress. So the next thing we'll do, we'll jump in is for classification, but I'm afraid we will not be able to finish up the given the time that we have. Well, let's see where we get from here. Let's see. Okay, so please, is anyone still working on the exercise? We're about to switch to a classification problem.
No more working on it. The place I'm using for
Okay, okay. The place you're using to follow along, they closed. Hello? All right, so the next thing we're going to do, we've seen how we can use sklearn to, do work out linear regression. You can see that it's stressless. There's no stress in there. You just pass in the x value, pass in the y value, and just be putting dot what you need, and whatever you want, and you pass in whatever you want. Now, we spoke about classifications another way of when we talk about supervised learning. We said we can have prediction. We've seen prediction. Maybe we want to do stock prediction. We want to predict, failure in a particular system. Or we want to predict who will win the next World Cup, who will win the next Olympic, and all, whatever it is you want to forecast. You can do a forecasting already right now. So what we want to see is how we can work with classification problem in a supervised learning, let's say we have data that are labeled, and then we just want to see how the classification works. All right, so for that I'm going to open a new notebook entirely. I'm going to open a new notebook entirely for that, so we can run through that, and I'll be straight as much as possible. Okay, so pretty much like we did earlier, so I'm going to import our Scikit Learn. So from sklearn dot linear model, similarly I'm going to be bringing in logistic regression this time around. Logistic regression algorithm. From linear model, we'll bring in logistic regression. Okay, so, and that's all we have to bring in. So the next thing we want to do is to also bring in data that we want to work with. So this time around we are going to be working with data set that is available on Scikit Learn itself. So there are some data sets that's available that you can work with. You have toy data sets, you have some real world data sets, you have generated data sets, you have loads. So we can use these data sets to just run some for quick learn rather than having to look for data. So that's what we're going to be using. We've seen how we use our own data that we have locally, so it's not different. So but let's see how we can work with this data. I'm going to be working with wine data, this wine recognized data set here. So to do that, I will just bring in the data set from the sklearn. So I will say from sklearn.datasets. All right, so I'll bring in what I need. Load wine. So from sklearn.datasets, import load wine. All right, so that gives us the data that we need. And now I'm going to get out x and y value from this data set that we've just loaded. So we say xy value equals to load wine as method, right? Load wine as method, and then we'll return xy value. Return xy value. Xy value, we'll pass that equals to true. So the moment we do this, we should have, all things being equal, we should have x and y value. So let's run this. All right, so let's get what x is. Sorry, this true is capital T. Logistic regression. So let me see what it's saying. I got an unexpected keyword, return xy. Load y, return xy equals to this. What is this guy saying? right, so there are a couple of these functions that so it's return xy is like this, capital X and small y, return xy like this, and then x value, let's get our x value. So we have x, capital X, and then you have small letter y, xy equals to true. So what you did here is that you pass in the first value being x, the second value, this is your variable. It doesn't have to be xy, but of course this is return xy returns dependent and independent variable, and this one you can pass it as anything you want. You pass in, so the first value serves as x value and the second one serves as y value. So let's see, just for the sake of visualization, let's see what y also looks like. So we just got those data out from load wine, and so there are plenty data there in front of 0 and 1, so we don't really know how many data that contains, because of course it's not our making, and most of the times when we're working with big data, we are not going to know that as well. So this next thing we're going to do is to divide our data into two. We're going to be using one data set for training, and we're going to be using another data set for testing. So we'll use some data set to train our model, and then we'll then use another data set to test our model, right? So now when we test, we can compare the data that we keep somewhere with what is being predicted. So we can compare it and say, okay, yeah, this guy is correct. So that's what we normally would do. Divide the data set. So you decide what percentage of your data set you want to use as for training, and what percentage you want to use for training and for testing. All right, so to divide our data set into training and testing, we are going to import a package or a method that can help us to split data into two. So you can split it manually, but of course you just have this guy. So for us to do that, we are going to use train test split. So from sklearn.model selection, I'm going to import train tests, splits. All right, so from sklearn this, we're going to use train test splits, which we would be using to split our data into two. Now with this, we're splitting our data. So let's say we name this x train. Let's say we say x train, which is effectively means the x value that we're using for training, then comma x tests, s underscore tests, which is x value that we'll be using to test. All right, then y train, then again y test is equals to, so we're going to be using this guy that we brought in, train test splits, to split this out into the x, the y, x and y. Now you then specify the test size. This is pretty much up to you. Test size, what portion of your data are you using for tests? Everything in the data set represents 100%. So maybe you want to use 70% of the data set for the training, and then 30% of the data set for testing, or you want to use 80% of the data set for training, 20% for data set, or you want to use it 50-50, 50 for training, 50 for data set. So here, when you say test size, you specify the percentage If you say, for instance, you want to use 40% for testing, then you say this one is 0.4. This is 0.4 automatically means you're using 40% for testing, which implies that you're using 60% for training. You don't have to specify train size. Test size 0.4 means train size is 0.6. So if you say test size is 0.2, it means that train size is 0.8. This is you are dividing your data into two: 40% for testing, and then the other percent for training. So let's say we have that is 0.4 for testing, and then you put random state. Now, so random states, this takes random state as well. This takes an arbitrary value, or you can specify value. Sometimes people use 0, but you can use any integer. You can use 0, you can use 42. Most number that is most used is 0 and 42, but it's not like you can only use 0 and 42. What does this random state really mean? The random state means that when this guy that is splitting the data will normally just shuffle and pick data randomly from your data set. And what the implication of that is that each time you run this, you are going to be getting different results, because different data set is used for, each time you are not sure of which data you are using. But when you specify random state and you specify a specific number, it means that it's going to use that number as the state value, which means that it's going to pick the same number every time. So if you run it the first time, you get the same result. If you run it again, you're going to get the same result. That way you are being specific. But if you want to use random states, if you don't specify random states, it's just going to be each time it shuffles the data and just pick it randomly. So if you say random state and I use the de facto, let's say 42, or you can specify any other number. That way you're just specifying, you are being static about your random state. Your random state is going to be static. So it means that the shuffling of the data is going to be one way. So once we do that, we get that out. All this being equal, I hope I have not written any typo. So here S train, X text, Y train, Y text. So we're going to get that out. 40%, 60% for training, and 40% for testing. If I put 3, I'm using 70% for training and 30% for testing. So you can iterate that out from your data. So the next thing you want to do is you may want to check things out and check what your I think we imported this afterwards, so that the train test, we imported it afterwards. So we need to have it into the memory, and then so that this guy can work. Yeah, I put dot here instead of comma. Okay, so that works. Now, so you can get out the value that you are using for training to see how it looks. You mustn't look at it. All this one we are doing here is not like you have to look at what you use. It's not a must, but it's just because we are here and we may want to just see things out. So this is the value that we're using for training, just to be sure that everything that we've written, and then what we're using for testing as well, the value of X that we're using for testing. You can check that. You can also optionally on your own check out the Y values, and you can check out the Y value, the Y train and the Y test value. So I'm just going to move on to conserve time. Move on to doing the work. We are done, really. We are done. So the next thing is just to call our model.
Sir, my own X train and Y train is different.
I hope it's not linear regression you are bringing in. Did you use train test size?
I imported the logistic
and
regression,
then
sir.
Here, are we using the same parameter? Because I eventually changed this guy to 0.3.
Yes, I changed it to 0.3
Did
as
you
well.
use 42 as your random state?
No, sir.
Yeah, use 42. So, but where is the training is speaking from the same data to train the model. So even if our results eventually, whatever we are classifying, even if it's going to be different, it's going to be very close, because irrespective of what you are using as your random state and it's speaking the data, since it's from the same data set that it's learning from, so it should be able to classify correctly going forward. So when we give it another kind of things to classify, it should be able to classify it since it's same data set. But if we want to get something similar to what I'm getting, you may want to use my parameters. So moving on now, the next thing we want to do is to declare our model equals to, so if you have brought that guy as with Elias, you will have called that Elias, but let me just say that this linear regression, logistic regression, we instantiate it, and then the next thing is to give it the data. Model.fit, we give it the data, x train, the data we want to train it with, s train and y train, and y train. All right, we'll fill that in, s train, y train. Yeah, and it has learned. It's learning. The moment you do this like this, not like you human that you use a whole week to learn. So you just use this and it learns the data. Then from the data, you can do the classification. So the next thing we want to do is to check out the prediction. Okay, so prediction or the classification is, we're going to have this out as so let me say I call it prediction or I call it classification, whatever name you are calling it. Okay, so let's say we have this guy. So this is going to be equals to our model dot predict I hope I wrote that predict well, and then we pass in the x text. So it uses data to learn, and based on what it learned, is now going to classify. So we have x text, x underscore tests. All right, so that gives us our classification. And then the next thing I'm going to do is to bring in classification reports, really. Or let's call this guy prediction, so we don't get things confused. Let's get out.
Sorry.
Yes.
Sorry, sir. Let me cut you a bit. I got this particular error. Total number of iterations reached limit.
Yeah, it's not. There's nothing wrong, really. It's
Okay.
there's nothing wrong. It's okay. You can write on, but it gives you certain value.
Okay.
But then it's trying to still iterate through. So depending on, because this data
Okay.
set is loading from a server, so depending on what is available at the time.
Okay.
So I've seen that error so many times.
Okay.
So there's nothing wrong with your implementation. You run it again, you may not see that error again.
All right. Thank you.
So you have the prediction to be this. You can check out your prediction. That's y prediction. So we have this. So you can see the similar error that you got. Total number of iteration which limit is this and like that. So it's nothing special. So you have this guy here, prediction. Okay, so the next thing we want to do is, or like I said, it's not like you have to, you know, check at your value, but I just like seeing what I'm working with. Now, so next thing we want to do is to check the accuracy score, which is what we did, pretty much like our R square in a linear regression. So let's bring in accuracy score here, you know. So from Scikit Learn metrics, accuracy score is inside Scikit Learn metrics, the same place where R square is. Scikit Learn dot metrics. So Scikit Learn has all of this. So from metrics, we are going to import. Sorry, let me put off this one. Totally forgot. Okay, so I'm going to import from Scikit Learn metrics. I'm going to import the accuracy score. Sorry, accuracy underscore score. Okay, so I'm going to use that. So I will run this again so that accuracy score is loaded, and then we can use that to check out our accuracy score. Accuracy score. So the level of accuracy is equals to the accuracy score, and then we pass in the predicted value, this prediction, and then y test. So we check this out, the prediction and the y test. So with that, let's see, let's echo out our accuracy. Let's see the value of the accuracy. Yeah, the confidence level is high, 98.148. That's the accuracy level based on this data set. You see the accuracy level would be changing depending on this thing, the portion of your data that you use. If you change the test data to say 50%, if you check this, the more data that your model has to learn, the perfect it becomes. The more data it has to learn from. So if you increase this test size to 50%, for instance, it means it has less data to work with. You can check that the accuracy level will not be the same as that. So you have that. But of course, depending on the quality, the data quality that it learns from. So let me take this back to this, and then we have that. The next thing is to report the classification. Let's see what is being classified. Let's see what is being classified. So for us to use classification reports, we have to import another thing, which is from metrics as well. Of course, you can use import it from. So let's say I will just use it basically like this. From Scikit Learn metrics, we're going to import classification reports. Classification reports. All right, so we'll use classification report to see the data that is classified based on the prediction. So here, so let's say we call this, that's why I changed that guy to, so let's say we have classification to be equal to classification reports, and then we put in our prediction, comma, and then we put the y test. Okay, y test value. So the moment we do this and check out our classification, we'll see classification report is not defined. I think we have not run this guy again. After we imported this, we have to run this guy again. So our classification reports get loaded, and then we would run this guy again. Yeah, so it gives us the classification. So the classification that you have here, you have precision level, we have recall, we have F1 square, we have support. So there are some value in the data set that we have. I think this guy is not pretty well labeled. So we have 3 data sets, 3 type of item in that data set. N weighted, we have this is pretty much not showing the data properly, but the headings that you have in here, you have the precision, you have the recall, and then you have the F1 square. This one here, F1 square, is pretty much like the confidence level that you have here. So when this is qualified, and then support, it tells you, let's say you have green balls, how many green balls you have. So when you see something under support, you have 22 of it, you have 54, you have 54. So we have 24, 54, 50, 52. These are the records that we have in this. So this recall and precision, you know, they have their own formula, and I'm going to show us here. The precision, of course, tells you the level of accuracy. So the precision, this is precision. This is the formula for calculating precision if you have to do it manually, but of course we don't really care, since Scikit Learn is doing the logistic regression for us, and then we don't, let's just do these predictions and then it calculates all the predictions and everything for us. So there is something that we call true positive. This TP here is true positive, and then we have something that we call false positive. So true positive divided by true positive plus false positive. Forget about this value, it's in another context that they have calculated their own, the manual approach, just like we did, trying to use true positive and all of those things. But here we just want to dive in and just take advantage of Scikit Learn rather than us going through the route of typing in the formula ourselves. But if we were to calculate the precision ourselves, so we'll have evaluated true positive, evaluated false positive, and use that to get our precision. This is precision formula, you know, and it tells us the level of precision of our data is. And then the second one that you have is the F1 square, which is of course the accuracy level of the data set that you have. It has this formula like this: 2 times, this is 2 dots, 2 times precision. You must have calculated precision before. Where is this guy here? So you have 2 times precision, and then times I think I closed the formula, so let me open it again. I put it here for our F1 square for our convenience. I said I wanted to show us. We don't have to know it, but I just like that when you are doing something, of course you know the couple of things behind it, and then you are able to interpret. That way you are able to interpret your results better. Okay, so the formula for that F1 square is like this, which is of course making use of the precision times recall, how many recall points it's your model has. So you have that, and then you have the true positive. So here I said true positive is number of true positive, false positive, and the number of false negative. So pretty much we have not explored how you can, get out the true positive parts and true positive. But of course, we should know literally what the true positive is. And then the recall itself has this formula. Recall attempt to answer the following question. What portion of your actual data, what proportion of your actual positive data was identified correctly? So mathematically it's expressed as this: true positive divided by true positive plus false negative. So, but we don't really care much. I don't want to take us through the turmoil of that calculations things that we have. So, but this guy here has done this classification for us. It doesn't make so much sense, and that's why I don't really like to work with data that we just get from anywhere, because we don't know the configuration of the data, and then how do we know what is classified and what's not classified. So what we work towards then is to be able to load in our own data ourselves, and then just like we've been doing, and then see how things can be classified. And then it will even make more sense later on. Let's say you just give your machine model certain random images or random medical records, and then you ask it to classify the records based on whether they are sick, whether they are normal, whether they are stuff like that. So, and that is where we'll get to eventually. But this one is just to introduce us to the classification and using the existing data set from the Scikit-Learn. We extended our class way beyond the normal time. So I appreciate that it was going to be like that, but there are a couple of in between that we equally paused. So I hope if you go through this video again, and then you try to work with other data sets, there are a couple of other data sets, just like I've mentioned here, you can work with, and then try to just increase the fluency of your linear regression. This is a linear logistic regression algorithm. So there are a couple of other classification algorithms that we could have used, but we just use logistic regression. Please, are we together?
Yes, we are.
Yeah, it looks like we are very tired.
But sir, I have a quick one. So for this classification part, the one we did last, is there any package or any model that we could use to better show the table instead of this scattered data that we have like
Yeah,
this?
the funny enough, it doesn't usually. I think it's this system that I'm using here. It's with the data that you have in that classification that you brought in is accuracy, and then macro and weighted. So there are three distinct: accuracy, macro, and model, and weighted here. I think the function of the resolution of what we are using here, the function of resolution of what you have here, really. You get, so it's there's no, you don't really need any package.
It's playing alike on my own laptop too. That's why I
Yeah,
asked.
I get it, but it's a question of resolution. In my laptop that I use for data distance, each time I do it, it doesn't even, you know. But this, I'm using this so that everybody would go along. It has basic setup, like that. But it's not. You don't really need any special package.
Okay, got that. Thank you. One last thing. Can you please scroll up a bit to where you have your model and prediction? I just want to, yeah, no. Yeah, this part. I just want to confirm something. Okay, I've seen it. Thank you.
Okay, so let me see. Instead of us doing, let me see if I print this guy out. instead of let me print it, it might show better. If we use a print, let's see. Aha.
But
If
sir,
you use
our doesn't tally, but they are closely
yeah,
related,
you know,
kind
it's
of.
it's a blind beast. So if you use print, you can use print to get it out. You know, print is an echo method. You know that we use to print you print things out. But of course, we've just been doing manual. So print it out, and I think you should have proper perspective. Have you done that, please?
Yes, I
Okay.
did. That's
Okay.
great.
Okay. All right. So thank you, everyone. Please go through. Let's continue the question and answers on the channel. Thank you very much, and see you next week.